Welcome to one more Flip Classroom math video. 3 tips before you start. First, you can slow down or speed up the playback if that helps you watch the video at your own pace. Second, you could pause the video any time to jot down notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. Today's topic covers the chain rule. Now this is a rule that we use to differentiate composite functions. So let's check one of those out. Here we have 2 different functions. It's all put together in one, but it's written in a sort of a composite way. So we have this inner piece, 1 minus 2x, that can be considered one function, and then we take this whole inner piece and we square it, and that can be considered another function. So right now we do not have a rule that helps us differentiate this. Actually, we do. We can expand this by multiplying it by itself, foiling it, and then differentiating the resulting function. So let's go do that. Let's pause the video and go do that, and then I'll show you how the chain rule makes this quicker. All right, here's what I did. I just expanded this out. This is a binomial times itself, so that's that. I foiled it through, and then I took f prime of this function. The 1 goes away, the minus 4x becomes a minus 4, and plus 4x squared becomes 8x. So that is truly the derivative of f of x. But we don't have a rule that we can apply right to that. We have to do all these steps before we can take the derivative. So let's take a look at the chain rule and see how that makes it go faster. Okay, let's take a look at how the chain rule works. And before we start, I put my answer here for when we differentiated it by foiling and doing all the algebra first, then taking our derivative. So that was our answer. When we get done with this, we're going to see we're going to wind up in the same place, but with fewer steps. So check this out. I'm taking this function, and I'm saying if u of x is the inside function, that's the 1 minus 2x right there, and then v of x is the whole thing, the outside function, that would be 1 minus 2x to the second power, then f prime of x, the derivative of this function, is just going to be u of x or the derivative of u times the derivative of v. So let's look at how that works out. Okay, so check this out. I just did my u of x, that's this one here. Remember that my u is my inside function, so 1 minus 2x, the derivative of that is just minus 2, so there's that. And then I took the derivative of this by just taking my 2, putting it in front, reducing the 2 by 1, so now I have 2 minus 2 times 1 minus 2x. So that condenses down to minus 4 times 1 minus 2x. If I do my distributive property, I wind up here, which is how we wound up here. So this is a little quicker than having to actually foil something. And guess what? You might do something with a 3rd power or a 4th power. You don't want to have to foil those things out. They take a long time, lots of chances of making mistakes. The chain rule is quick and easy. All right, let's do a bunch of these derivatives using the chain rule. So here's one. F of x is 2x to the 3rd plus 6x squared. I want you to pause the video, look over your notes, use the chain rule to differentiate this composite function. All right, here we go. What I did is I took my inside function, I took the derivative of that. This gives me 6x squared plus 6. That's the derivative of that term. And then I did the whole thing as a derivative. So I moved my 2 down in front, and then I just put that in there. There's a 1 there because we reduced that by 1, but we don't write it. And then I just rearranged a little bit, put the 2 in front, and we have this. If you don't get the prompt to fully expand your answer, you can stop right there. Okay, so I did this problem in the original video, which I have since deleted off of YouTube because I had a mistake in there. I left the squared off on the x when I took the derivative, and it was kind of messed up. The answer wasn't right. So I'm coming back at a later date on my weekend, hence the casual attire, which is not usually seen in my video, but that's life for you. Okay, so let's take a look at this derivative. Here we got f of x is the square root of 5x squared minus 2. So think about how you're going to break that up so you can do the chain rule. Okay, just to get you started, I have to remember that the square root is the 1/2 power. So now this one is more accessible. So if you haven't already done so, pause the video and take the derivative of this composite function. So if you remember, what we do is we take the derivative of the inside piece, the function that's buried in the other function. So that's the 5x squared minus 2. Taking the derivative of that is just going to give us 10x. Okay, so there's that one. Now what we have to do is take the derivative of the entire function by moving the 1/2 in front, leaving the middle the same, and reducing the power by 1, which gives us negative 1/2. So if you haven't already finished this problem, pause the video and finish the problem. Okay, so 10x times 1/2, that leaves 5x for this part. It's all multiplication, so I can just group however I want. I'm going to take this part with a negative 1/2. That's going to be positive 1/2 power below the fraction bar, so I leave a 1 up on top as the placeholder. Now I'm just going to combine across. My 5x goes on top. The 1/2 power is just the square root, so I can write it more simply that way. Now remember, a standard for simplification is no negative exponents and no fractional exponents. So that's why we did that. Okay, here's our last problem. For some reason, I never recorded the introduction to this problem, so I'm doing this right now on the fly while I'm in the middle of editing the video, but that should work just fine. So here's our function. F of x is 2 over the square root of 1 minus 3x. So what I'd like you to do now is pause the video and use all the rules that we've been doing so far with your fractional exponents, taking derivatives, etc., to find the derivative of this composite function. Okay, let's see how you did. So check this out. I have a root under the fraction. I don't like roots. I don't have rules for dealing with roots, so I change them into their exponents. So this would be 1 minus 3x to the 1/2 power. But again, I can't do it on the bottom of a fraction, so I bring it up. So this expression becomes 2 times 1 minus 3x to the negative 1/2. A necessary step before we can start applying the chain rule to this composite function. So check this out. So now what I do is I'm taking the derivative of the inside bit, which is just going to be minus 3, and then I take the derivative of the whole thing. So I'm bringing my 1/2 down, my negative 1/2 down, multiplying it by my 2, and then here's my binomial, and I have to subtract 1 from the exponent, so I'm going to have negative 3/2. So this is all broken out, that chain rule step. Now we're just using a little bit of algebra to combine things up. So negative 3 times negative 1/2 times 2 is just 3. And then what I did is I brought this negative exponent down to the bottom, so I have 1 over 1 minus 3x to the 3/2. Now this can be simplified down. 3/2 is just the square root of that thing to the 3rd power. So I simplified my fractional exponent, made it like so, and then my 3 just goes to the top. So there is my derivative of that composite function. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.